So if we look at the image that's drawn on the screen, we'll see a very simple circuit. This is a circuit that has one resistor in it, the resistor being the light bulb, and it also has a switch. So if I were to draw this actual circuit as a circuit diagram, a little bit of a refresher here. We've got our power source, and then our image for a switch is like so, coming down to our actual resistor, which is a light bulb, and then going back to the power supply. Now, the image on page 459 shows conventional current leaving the positive and traveling down through the switch. And if we assume that this switch is open, that's going to cause this little light bulb to actually light up. Okay, we're assuming that the current is actually traveling through this from positive to negative. When in reality, the idea of, conventional current was established long before we knew that actual electrons moving around in these circuits actually leave from the negative and they travel around the circuit like so. Okay, and back up through. That's why we say it always leaves black when you're setting up a circuit diagram, and it comes back to the power supply via the red knob or the positive knob. Now, if we look at this, okay, this circuit, if we look at this circuit and the light is on, there's a few things going on here. And we're actually going to play around with this when we set up our circuit. There we go, that's touching. So right now this circuit is on. I've got my power supply over here, right? I've got my switch. I've got my resistor or my light bulb. Okay, either or, it's slowing down the current, it's taking up some of that energy. And I've got my negative supply here, so we'll call this a light bulb. Now, there's a lot of things that go into, actually, this is a pretty simple circuit, but there's a lot of thought that goes into setting up any type of circuitry in a building, in a machine, and we're going to look at the electrical engineering component of the idea of circuits. This doesn't involve actual calculations, like Chapter 5 did, but it involves understanding why the parts of the circuit are actually in the circuit. So we're going to look at different components that have to be in a circuit, and one of the first things we're going to talk about is a power supply, because you cannot have an electrical circuit that does not have a power supply. I mean, you can set up a circuit, this circuit here, okay, this simple circuit on the first page, easy to set up, but you will never actually get the resistor or resistors to do something in the circuit if you don't have an actual power supply. And we're going to look at 3 different types of power supplies, advantages, disadvantages of these. And the first 2 are fairly common, the first one being a battery. So if we look at a battery, okay, a battery is a type of chemical energy. All right, it's basically, through chemical reactions, it's releasing electrical current. And we know batteries as being, these little, we'll draw a little AA battery here. It's got the positive side that goes down to the negative side on the bottom. So negative down here, positive up top. The circuit actually has to go from one to the actual light bulb down into the other end. Now, the advantage of a battery is that it's portable. You can take it a variety of places. The disadvantage is that it does run out. And interestingly enough, when you actually have batteries and you buy batteries, batteries start losing, I guess, their amount of chemical potential energy from the moment they're actually made. So if a battery's been sitting on a shelf for 5 years, it's going to have, even though it's brand new still in the package, it's going to have less, potential energy to offer. Now, the other type, which is something that we, use the most, is the idea of the electrical outlet. Okay? Outlet, we see these in homes. Ours look different, let's say, than those in Europe. They're usually 2 plugs that will have a larger, smaller, and then a round opening. A larger, a smaller, and a round opening. Now, the cool thing about electrical outlets, and especially when we look at an actual plug, if you're looking at an actual plug that's going to have, its surface and the cord dangles down, you'll usually have one larger, more circular one at the bottom, and you'll have 2 straight ones on the sides here. So if you're looking at the base of the plug, it fits into one of these. Now, it works the exact same way as a battery does. Okay, one of these openings here ends up being, let's say, your negative, whereas the other opening over here ends up being the positive. And then that third actual opening is called your ground. No actual current goes through the ground. And a lot of times, in certain appliances that are cheaply made, sometimes the ground portion of a plug will actually, get stuck inside the outlet or whatever. And it doesn't, the plug should still work. The actual appliance that's being plugged in should still work. Now, this energy is attached to power lines. It's attached to larger wires inside a dwelling, which then get attached to different types of power lines outside. So there's a constant supply of actual energy, and most of it is renewable and it's hydroelectric. The disadvantage is you can't really take it anywhere. You're stuck at that actual location. Okay? And then the final one that we're starting to see more and more of is something called the photovoltaic cell. Now, a photovoltaic cell, and I mean, they come in a variety of shapes and sizes, but we're just going to draw a little grid here, and it's usually a darkened color, so it's usually a little bit dark, and you'll see that it's got a bunch of lines on it. And the material that photovoltaic cells or solar cells are actually made from, what they actually do here is they transform radiant energy, so light energy, into electric energy. This is how solar cells work. Okay, so here we've got chemical to electric, and here we've got, hydroelectric to electric, and here we've got radiant to electric. Now, the cool thing about photovoltaic cells is that with technology, they're getting smaller and smaller, and they're getting, more and more versatile. We can see that photovoltaic cells can power very small objects in really remote locations. Okay, we see that with researchers that have, photovoltaic cell phones and chargers and, heat sources and water purifiers and whatever. The downside to this is that A, they're expensive, and B, well, you kind of need sunny weather. If you don't have strong enough light, the photovoltaic cell will not work. So this is a basic overview of the 3 main types of power supplies that are always found in circuits. In the next video, we're going to talk about other components of circuits. And yeah, we're going to talk about insulators and conductors as well as controls. So if we go back to this actual image here in this first page, we're going to end up talking about how we get energy or current from the actual power supply to the actual resistor. And that happens with the help of wires. Okay, and then finally, when we talk about controls, we're going to be looking at switches and the turning on and off of actual circuits.